For more information on tutoring, personalized video solutions, or how to support Moof University and the production of more videos, check out moofuniversity.com. Thank you and enjoy. So first up, we're going to learn how to name ionic compounds. And specifically the three subclasses, we're going to name ionic compounds with monatomic ions, and we're going to learn how to name ionic compounds with metals that form more than one ion, and also the ones from polyatomic ions. Okay. Now they're all really the same thing, but I split it up just to make things simpler. Okay. Now the general rule with all of them though is that we name the cation first, and then we name the anion second. Okay. That's for all three cases. Okay. So let's start off with the ionic compounds from monatomic ions. For the cation, what you do is you simply name the metal. Name the metal. And then for the anion, the nonmetal's ending is changed to "ide," right? You have the element name's root ending with "ide." Okay, so let's do a couple examples here. Name the ionic compound that would form between the two listed elements, magnesium and fluorine. Well, magnesium would be the metal, right? Magnesium is a metal, and therefore it would be the cation, right? And fluorine is the nonmetal, and therefore it would be the anion. So for the cation, I would just name the metal. Okay, so that means that would be magnesium. The name would be magnesium something. What am I getting to? Well, for the anion, that's going to be the fluorine. The nonmetal's ending is going to be changed to "ide." So fluorine would be fluoride. So magnesium fluoride would be the name of that compound that forms between magnesium and fluorine. Okay. What about the one that forms between sulfur and strontium? Well, sulfur is a nonmetal. I'm just going to abbreviate that as Nm. So that would be the anion. And then strontium is the metal. I'm going to abbreviate that as M, and that would be the cation. So for the cation, I just name the metal, right? So that would be strontium. Strontium. And the anion is going to come from sulfur, and that would be sulfide, right? So strontium sulfide would be the name of the ionic compound that forms between those two elements. Okay. Now, what about their chemical formulas? Well, if I think about magnesium fluoride, well, I'm going to have magnesium ion, Mg2+. I'm going to have fluoride, F-, right? These are ions that I had to have had memorized, right? And so I'm just going to do the crisscross method, right? This number goes here as a subscript, and this number, which is not explicitly listed as a 1, right? That's going to go here, right? But 1s are not explicitly written, so that would just be Mg1, but no subscript actually written, MgF2. Okay. And then for strontium sulfide, strontium is Sr2+, right? And sulfide is S2-. So crisscross, right? This number goes down here, this number here. I kind of covered up that 2 there. So that would be Sr2, S2, but this is an ionic compound, and we write things as the lowest whole number ratio between the two ions. So it's actually going to be SRS, right? That'll be it there, right? And then MgF2 for the previous one, okay? Now, since we're talking about a crystal array of many ions, we don't have a molecule, right? We've got formula units that we're talking about here. Formula units, which give us the ratio of cations to anions in the crystal, right? So here we got the ratio of 1:2 for magnesium fluoride and 1:1 for strontium sulfide. Now, strontium sulfide, this lowest whole number ratio, what type of chemical formula is that? Well, it's an empirical formula, as we learned in the video about the different types of formulas. It's an empirical formula. In fact, nearly all ionic compounds have empirical formulas as representing their formula unit. Okay, there are a couple exceptions. One example of a type of exception is compounds with the Mercury 1 ion, okay, which is the Hg22+, right? And so the correct thing, if we had Mercury 1 ion with fluoride, for example, we'd have Hg2 2 plus and F minus 1, right? So this would go here and this would go here, right? And now in that case we would imagine putting parentheses around that to put the 1 there, but since the 1 is not going to be explicitly shown, we don't need to put that. And so what we end up getting is Hg2 F2. That would be correct. Now we don't simplify this because it's not actually just Hg plus 1, right? So we don't get this. That's wrong. It's Hg2F2. So in that case, that's an exception to this idea of the empirical formula rule. Okay. Another example is alkali metal peroxides. Okay. Now peroxide is O2 2 minus. Okay. And same idea though, right? If I have sodium and peroxide, sodium ions Na plus 1, and peroxide is O2 2 minus. If I crisscross, right, put that 2 there and that 1 outside there. The 1 doesn't have to be explicitly written. That would be Na2 O2, but I can't simplify this because it's not just an O minus 1 ion, right? It's an O2 2 minus. So this would be correct instead of this. Okay. I hope that makes sense. That's a little bit kind of messy, but I hope that makes some sort of sense. Okay. Next up. Ionic compounds with metals that form more than one ion. Okay. Now, if you recall, metals that form more than one ion have systematic names as well as common names. So we're going to show both here. So for systematic naming, for the cation, you're gonna basically put the metal name followed by parentheses with the Roman numeral with the charge's magnitude. Okay. And then for the anion, you're just going to have the nonmetal ending with "ide," right? Okay. So, for example, if I have Fe2 plus and Cl minus, I'm going to have this 2 go here, the 1 go here, and I'm going to get FeCl2. That's my formula. So that is a combination of iron 2 right here. Right? So that's going to be iron, or parentheses with the Roman numerals, iron 2, and then the Cl minus is chloride, so it's going to be iron 2 chloride, right? Because the nonmetal ending has to be "ide." Okay, and then for Fe3 plus, that's iron 3, right? And we still have chloride here, so FeCl3 would be the formula there, and so the name would be iron 3 chloride. Now, for common naming, that's going to be a little bit different, obviously. The real difference, though, is going to be coming from what's going to be going on with the name for the cation. Okay, the anion will be named in the same way. You just add the ending "ide" to the nonmetal. Okay, so it's a matter of what we write before that. So for the cation, you have the common name ending with OUS for the charge with the lower magnitude, right? And then the one ending with IC for the higher magnitude of charge. Okay, so Fe2 plus is ferrous, right? And then after that, we would just put chloride, right? Fe3 plus is ferric, and then we would just put chloride, right? So FeCl2 is either iron 2 chloride or ferrous chloride. Both of those names are correct. And FeCl3 is iron 3 chloride or ferric chloride. Again, both are correct. But I care more about systematic naming. I'm probably going to use this more often than the common naming. Common naming is kind of whack. Anyway, so let's do an example here. What's the chemical formula for lead 2 oxide? Well, what I would do is go from this name immediately writing the actual ions, right? Like, what is lead 2? Well, lead 2 is Pb2+, and that I just have memorized, right? What is oxide? Oxide is O2-. So crisscross method, this number goes here, this number goes here, so that's going to be Pb2O2, but then I'm going to get the empirical formula, right? Lowest whole number ratio of these ions, that would be PbO. So that would be the chemical formula for lead 2 oxide. Okay. What would it be? What would be the name of Cu2O? Well, what is Cu2O? When I look at this, I look at Cu and I recognize, okay, Cu, that's a transition metal, and that can have more than one charge. So I don't know which one that is immediately. Well, I do, but I've studied this for countless hours. But when you look at this, right, you look at the metal, and you realize that it can have more than one charge. You use the nonmetal to help you figure out what that metal's charge was. Okay, so oxygen, I know that oxygen as an anion is oxide, and that always has a -2 charge. So that O is an O2 minus. So what did this Cu had to have? What must it have been if this is the formula that resulted? Well, if that's a formula that resulted, what I could do is kind of work backwards with the crisscross method. This 2 must have gone up here, and this 1 must have gone up here. So the 2 minus, right, this 2 becomes a 2 minus on oxygen. What must have been the charge of copper in order to yield this particular chemical formula? Well, in order to get that, copper must have been +1, right? Because if I do the crisscross method now, right, then I get Cu2O, right? So I know then that it's Cu +1, right? And so that is copper 1, right? So this would be copper 1, and this O2 minus is oxide, so copper 1 oxide, which of course there's copper 1 and there's also copper 2, right? Copper 2 would have been Cu2 plus, right? And just to kind of show you over here, that could have been Cu2 plus and O2 minus. That would have ended up being Cu2O2, which of course would simplify down to CuO. And so that's the formula that we would have had if it was copper 2 oxide. But that's not the case here, okay? So it could have been, I could name this as copper 1 oxide, right? That would be correct. But if I'm using common naming, then that would be cuprous oxide, right? Again, I don't really like common naming, but that would be the correct common name, okay? All right, let's move on to ionic compounds that are coming from polyatomic ions, okay? So for the cation, you basically use what you've learned from the previous two situations, right? If it's a simple monatomic cation, you name it according to that. If it's a monatomic cation that can form more than one ion, then you use what you learned there. However, there's a little asterisk here, and the only time you don't use what you learned from the previous two situations is unless the cation is a polyatomic cation, right? Which again, there are a few of them. In that case, if you have a polyatomic cation, all you would do is you would just name the polyatomic cation. Polyatomic cation. Okay. And then for the anion, right, which most of the polyatomic ions are anions, you would simply name the polyatomic anion, right, according to its actual name. Okay, so if we have Na plus and NO3 minus, we've got Na plus, this is sodium, right? And we've got NO3 minus here. We should have memorized that name is nitrate, okay? And the formula, if we do the crisscross method, we get NaNO3. So what is the name of NaNO3? NaNO3 is named sodium, right? We're using what we learned from that's the first section. And we're just, for the anion, we're just going to name the polyatomic anion, which is nitrate. So that is sodium nitrate. Okay. What if we have magnesium, right, with the +2, and we have NO3 minus, right? So now it's just magnesium. Magnesium, right? And then we just name the anion nitrate. And you'll notice here with this formula that it has parentheses in it. Why does it have parentheses in it? The reason why is because when you do the crisscross method here, this 2 goes out here and this 1 goes here, right? When that 2 goes out there, it's two of these entire nitrate ions, right? It's the entire nitrate ion that has this negative charge. So if I have +2, a charge of +2 coming from just this single magnesium, then I need 2 of these entire NO3 minuses, right? I need to have those 2 of these negative charges to balance out with that 1 + 2 charge from magnesium. So I can't just put the 2 I can't just write it as MgNO32. That would mean 32 oxygens, which is not right. when I put those parentheses there, when I put the parentheses here, I'm implying that there are 2 of these nitrates, right? So that's the idea of the parentheses there. And that's something you'll have to pay attention to when you do a lot of work with these polyatomic ions. Okay. So let's go through and name some of these, A, B, and C. So we've got Fe, and then parentheses ClO3, 3. So what is this? I'm going to split it up into its ions. I know that Fe is iron, but I don't know if it's iron 2 or iron 3. Okay. But if I look at this, I look at ClO3, and I know that's chlorate because I had to memorize that. So I know that I have an iron ion, and it's either a +2 or a +3. And then I have the ClO3, and I know that that's chlorate, and it has ClO3 minus. So in order to get that 3 right here, that must have come from the iron, and that's an iron 3, right? So I've got iron 3 here, and I've got chlorate. So what's that going to be? That's going to be iron 3 chlorate. That would be the name there. Or the common name, ferric chlorate. Okay. All right, next one, Ba, right, with this C2H3O2, and there's 2 of those. Okay. So I know that Ba is barium, and barium always has a +2 charge, right? And that's where this came from. So Ba2+, and then I have actually I'll get rid of those pluses. Ba2+, and then I have the C2H3O2. I should have memorized that as acetate, right? That's C2H3O2, and that has a -1 charge. Okay, so I'm going to name the cation, which is just barium in this case, and the anion is just the name of the polyatomic anion, which is acetate. So barium acetate. And that's it for that one. Next one, I've got sodium there. Sodium is always Na+. HCO3, I know that to be hydrogen carbonate or bicarbonate. So this can either be sodium hydrogen carbonate or sodium bicarbonate. Right? Both are correct. Right. So now you'll also come across some problems like this sometimes. They'll ask, is the following correctly named, right? And if not, correct it. So let's look at this first one. So this first one, we got CaNO3 2, right? So Ca, that's definitely calcium, so that part looks okay to me. I should split these up into its ions. That would be Ca2+, right? And we also have the NO3, that's minus, that's nitrate. So this says calcium nitrite. Okay, that's a problem, okay? Because, so this is definitely not correct, right? So the answer here is no. And it's simply because this NO3 minus is not nitrite, it's nitrate. So the correct name would be calcium nitrate, and that would be correct. All right, part B. B, we have K, that's potassium ion, so K+. SO4, that is sulfate, SO4 2-. Okay, so the name there should be potassium, okay, and then sulfate. Now this one's got something wrong with it, because this 1 is shown here explicitly in the Roman numeral. It's written as potassium 1 sulfate. That's not supposed to be there, because with potassium there is no ambiguity there. It's always +1, so you don't have to explicitly label that. So that's not correct. Instead, it's just potassium sulfate. So potassium sulfate would be the correct name for that. Okay. Now this one, we got Al, that's aluminum. Aluminum has a +3 charge. OH, OH-, that's hydroxide. Okay. So aluminum would just be named aluminum. That part's right. Hydroxide is the name of the polyatomic ion. Aluminum hydroxide? Yeah, that one's correct. That one doesn't need to be changed. Okay. I hope that video was helpful. Thank you for watching. If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you and happy studying.